Hello everyone, welcome all to our channel. Today we'll discuss about arc length of a circle. Let's consider a circle of radius r and let's take the arc length as s. Here I'm going to take this arc length as s and the radius is r. Let's consider this angle as theta. That theta should be in radians. So I hope you can remember the previous lesson where we learned about radians. So from the definition of the radians, we can write angle in radians, that is equals to arc length divided by the radius. According to this equation, angle we can write theta and arc length we can write as s and the radius is r. So easily we can write s is equals to r theta. Here you should remember theta should be in radians. Right, let's have some examples. Example 1. Find the length of the arc of a circle of radius 6 centimeters which subtends an angle pi over 6 at the center. So we know the equation, the formula that we can use, that is s equals r theta, and we should find the arc length is, we know the radius, that is 6 centimeter, and theta is from the radians pi over 6. So you can have the arc length as pi. Here the unit must be in centimeters. Okay, then let's move to the second example. Find the angle subtended at the center by an arc 22 meters in length of a circle of radius 21 meters. So using the formula s equals r theta, we know the arc is equals to 22 and radius is 21. We don't know theta. So you can write theta is equals to 22 over 21. Remember the units, that is in radians. Okay, next question. If an arc of 110 meters in length of a circle subtends an angle of 160 degrees at the center, find the radius. So what we have to do, we should use the same formula, S equals r theta, but remember theta should be in radians. But here in the question we have given theta in degrees. So we have to convert this one into radius. So you have to multiply 150 by 2 pi over 360. You can cancel 0 and you can cancel by 3. So that will be 5 into pi over 6. Now you can find the radius because you know arc is 110 meters, 5 into pi over 6. So you can write r is equals 110 into 6 over 5 over pi in meters. Further you can simplify this as r equal, you can divide by 5, then 22 into 6 over pi. That's it. So the next topic is the area of a sector of a circle. Sector of a circle. Okay, let's consider a circle like this. And we are going to consider the radius as r, center O, and let's take the angle, this angle as theta. So what I'm going to do, I'm going to divide all this angle into equal small parts like this. So let's name these 2 points as capital A and B on the circumference, and let's take the smaller one as C and D. Consider COD is one of the smaller angle. So we can write angle COD is equals theta over number of the smaller sectors. Let's take that one as n. N is the number of smaller sectors of this circle. Now according to our equation, S equals r theta, we know the total arc length that is equals to S, and we can use to find that for this length CD. So I will write CD length is equals to r into, what is the angle? COD angle, that is theta over n. Then r theta over n, that is the CD length. Now we need to think about this n value. When we are take a larger and larger and larger value for n, then CD becomes smaller and smaller and smaller. Then we can consider CD as a segment of a line, of a straight line, right? Then CD will become a smaller straight line. Then what will happen? Then the COD will become a triangle. COD will act as a triangle. So we can write when n is larger number, COD triangle, and we are going to find area of that is equals to half. The base will become CD, so that is r theta over n, and the perpendicular distance will equals to the radius r. So COD area will equals to r squared theta over 2n. Now we are going to find the area of the total AOB. Therefore, you can write area of AOB is equals to n into area of COD triangle. So that is equals to n into r squared theta over 2n. Then that is equals to r squared theta over 2. So this will gives you that area of a sector of a circle is equals to r squared theta over 2. You should remember here theta should be in radians. Okay, then let's move to some examples. First one. A circle has the radius of 4 centimeter. You should find the area of the sector subtending an angle of 135 degree at the center. Okay, you can try that with me. I know you are doing that with me. So what is the main thing? What is the basic thing that we are going to do? We can write the equation for area, that is r squared theta over 2, and we know the radius equals to 4, and we have given theta from the degree. So what we have to do first, we have to convert this 135 degree into radians. Come on, you can do this. 2 pi over 360. 135 should multiply by 2 pi over 360. Then you can simplify this. Then you will have the answer as 3 pi over 4. How can you divide that? You can divide by 45. Here you have 3, here you have 8. Then you can simply cancel here this one by 2. Then you have 3 pi over 4. Now you can find the area, that is 4 squared into 3 pi over 4 divided by 2. So finally you will have the answer as 6 pi square centimeters. Okay, then let's move to the next question. The second example. A sector of area 231 square centimeters is to be removed from a circular plate whose radius is 21 centimeters Find the angle subtended at its center. Now we should find the angle. So what we have, if this is the circular plate, and this is the sector, then area of this sector is equals to 231 square centimeters. So we can use the equation area A is equals r squared over theta over n 2. So area is equals 231. Instead of r squared, we can write 21 into 21 into theta over 2. So theta will equals 231 multiplied by 2 divided by 21 into 21. You can cancel this one by 21. Then here you have 1 and 1 again. So the answer is 22 over 21. This is from radians, right? So we can write this 22 over 7 into 1 over 3. We know 22 over 7 is equals to pi. Then we can have theta is equals pi into 1 over 3, that is equals pi over 3. Angle in radians. Okay, so that's it for today. Our next video is about circular functions. So I hope you enjoyed today's lesson and thank you for joining with us.